This is a video about Technology Airtime, which has two sides, Input Airtime and Output Airtime. Technology Input Airtime, the time when the computer system waits for the user to provide input like typing, clicking, or using a touch screen. Technology Output Airtime, the time the user waits for the computer to process the data and provide an output such as loading a web page, running software, or generating a result. This concept helps users and organizations understand how much time is lost due to waiting on the system or the user, which can impact overall efficiency and productivity. Reducing technology airtime, both input and output, can greatly enhance user experience and system performance. Reducing input airtime. Input airtime occurs when the system is waiting for the user. Reducing it focuses on improving user interaction speed and interface efficiency. Improve user interface design, or UI/UX. Streamline workflows by simplifying tasks and minimizing the number of steps users need to perform an action. Tools like wizards, autofill, and templates can speed up user input. Use predictive text or suggestions. Implement features like autocomplete or text prediction to reduce the amount of typing. Responsive design. Ensure that your interface reacts quickly to user interactions, whether it's a mouse click, touch gesture, or keystroke. Enable keyboard shortcuts. Provide keyboard shortcuts or gesture controls that allow users to perform actions quickly without relying solely on the mouse or touchscreen. Voice input and command systems. Use voice recognition technology for tasks like dictation or issuing commands to reduce the time spent on manual typing or clicking. Reduce cognitive load. Make the interface intuitive and reduce distractions, allowing users to find options quickly and easily without unnecessary complexity. Reducing output airtime. Output airtime is the time the user waits for the system to complete an operation, like loading a web page or processing data. Reducing this depends on optimizing system performance. Optimize system performance. Faster hardware such as upgrading to faster processors, increased RAM and SSDs can significantly reduce delays in computation and data access. Efficient code developers should, write optimized, clean code to reduce the time the system takes to process requests and output results. This includes reducing database query time with optimized SQL queries, minimizing the size of resources like images, scripts, or style sheets, and avoiding unnecessary loops or redundant operations. Parallel processing and multi-threading. Utilize techniques like parallel processing and multi-threading to execute multiple tasks simultaneously. This can really reduce the time users wait for results, especially for complex tasks like video rendering or data analysis. Caching browser caching. For web applications, storing frequently accessed data in the cache will dramatically reduce loading times. Data caching. Cache the results of heavy computations or database queries to avoid recalculating them each time. Content delivery networks or CDNs. For web applications, use CDNs to distribute content geographically closer to users, reducing loading times for web pages, images, and other assets. Pre-processing and preloading. Preload resources or pre-process data before the user requests it. For example, web browsers can preload content or images before the user even navigates to them. Efficient algorithms. For software applications, implement more efficient algorithms to reduce processing times, especially when dealing with large data sets or intensive computations. Reduce network latency. Use compression techniques for data transmitted over networks. Optimize the backend servers for quicker response times. Use asynchronous loading to load web elements, for example, scripts and media, without making users wait for them to finish before interacting with the web page. Improving overall system responsiveness. Prioritize user-perceived performance. Users experience delays differently, so focusing on perceived speed can help. For example, loading critical components first and then progressively loading non-essential elements can make the system feel faster. Feedback mechanisms. Implement visual cues like loading animations, progress bars, or placeholders to show that the system is actively processing, which can alleviate frustration caused by delays. Summary of key actions. For Input Airtime, focus on improving user interface workflows and interaction techniques such as shortcuts and voice control. For Output Airtime, optimize hardware code efficiency, network speed and data handling to minimize delays in system responses. By reducing both input and output airtime, you can improve system responsiveness, reduce user frustration, and enhance overall productivity.